Alright kids, we finished our first unit on one-dimensional kinematics. You'll never guess what the next one is. Ready, set, do this problem. Okay, so we're going to look at a very straightforward problem today. Let's say we have a nice tree with a nice hawk inside. That's what hawks look like. And right under the tree, there's a cute rabbit. And the hawk and rabbit are friends. Just kidding. The hawk's gonna eat the rabbit. It's a 30-meter tall tree. And the rabbit wants to run to its hole, which is 40 meters across level ground. The rabbit can run 4 meters per second, and the hawk can fly 5 meters per second. What do you guys think will happen? Will the rabbit reach the hole, or will the hawk catch it and eat it? Tell me right now. What do you think, Sage? The rabbit's gonna get eaten. Right, that's true. The rabbit's gonna get eviscerated by this hawk and chopped into pieces and fed into baby hawks. It's gonna be very sad for this rabbit. Why is that the case? The rabbit's closer. Let's see. 4 meters per second, 40 meters. It's gonna take the rabbit 10 seconds to run to the hole, right? Right. How long will it take the hawk to reach the hole? Well, the hawk's gotta fly down. That'll take 6 seconds, then fly across. That'll take 8 seconds. Won't it take the hawk 14 seconds? 6 plus 8? Won't the hawk reach the hole after the rabbit? Someone explain it to me. How come the hawk can travel 70 meters in less time than the bunny can travel 40 meters? How does it work? Tell me right now. Yes, Daisy? The hawk can fly diagonal. Wow. Oh yeah, right. The hawk will fly in a straight line. The hawk is so smart, and he's gonna just kill this rabbit so badly that he's gonna go this way. And it's a 3, 4, 5 triangle. Pythagorean triple. It's that triangle guy. He'll travel 50 meters at 5 meters per second in 10 seconds also. So they'll reach the hole at the same time, and the hawk will reach its talons in, grab the bunny out of the hole, pull it out, and just rip it apart with its beak and claws. It's going to be very bad for this rabbit. But yeah, that happens. So today, we're going to look at this. How does the hawk, moving 5 meters per second, reach the hole at the same time as the rabbit? How can that be? Well, it's because not only does the hawk have a speed of 5 meters per second, it also has a direction. It can fly diagonal. Something with a speed or a magnitude and a direction, you already know it's a vector. A vector. So we're looking at vectors. We talked about one-dimensional vectors, which were kind of useless. This is a 2-dimensional vector. It's a velocity vector of 5 meters per second. And I erased the whole drawing, but I kind of needed it back, so whoops. 5 meters per second, and it's an angle, it's about 37, I think, degrees below the x-axis. Usually in physics, when you're going to describe angles, just like in math with the unit circle, you can start to the right, this is the positive x direction, and then going counterclockwise, this would be like 0 degrees, 90, 180, 270. So if you wanted to get technical, this is a negative 37 degree angle, negative 37. Or 323 would also be an acceptable answer, but it's just that way, it's fine. So, I gotta redraw my drawing because I erased it erroneously. Tree, hawk, bunny, that's what bunnies look like. Hole. 50 meters, 30 meters, 40 meters. Is that big enough? Can you guys see that? Hopefully, because I can't change it. So too bad. So the hawk flew 50 meters at 5 meters per second. Not really realistic hawk speed, but go with it. It took 10 seconds. I know the hawk's speed was 5 meters per second, but in that 10 seconds, the hawk had actually 2 displacements. He displaced himself from the top of the tree down to the ground, 30 meters, and he went from the tree's location across the ground to the hole, that's 40 meters. So in that 10 seconds, the hawk made this movement and it made this movement. How fast was the hawk moving up and down vertically? How fast was the hawk moving horizontally? Tell me right now, how fast was the hawk's vertical motion and how fast was the hawk's horizontal motion? If you look at just horizontal, how fast did the hawk go? If you look at just vertical, how fast did the hawk go? Well, it's a pretty simple problem. If you know formula V equals d over t, it took 10 seconds, so just divide by 10. It went 3 meters per second downward and 4 meters per second to the right. How can we visualize this in a nice way? I know. Do you? Hopefully you do. We can make a 3, 4, 5 triangle that shows it. Think about this. The hawk was flying 5 meters per second diagonally. But an equivalent way to say that, the hawk wasn't flying 5 meters per second. The hawk was flying 4 meters per second horizontally and 3 meters per second vertically at the same time. It sounds weird because it adds to 7, but not when you're talking about vectors. The hawk did travel the 40 meters across in 10 seconds, and it also traveled the 30 meters vertically in 10 seconds. So it did go 3 meters per second and 4 meters per second, but that doesn't mean it can fly 7 meters per second. That actually only adds up to 5, which sounds confusing, but we'll get back to it later. And it does make sense. You know how you say you always cut corners? If you are trying to walk across the street and then turn left and walk across another street, but there's a nice park you can just run straight through the block, you're going to save time. You don't need to go as fast to have the same displacement diagonally across the park. You can move across it in less time going at the same speed than if you were to walk orthogonally in an X pattern around the blocks. Yeah. So this is a velocity vector. The velocity vector has 2 parts, magnitude and direction. The magnitude is 5 meters per second, and the direction, we'll call it negative 37 degrees. You could call it 37 degrees below horizontal. If we had a compass and it wasn't like a tree landscape thing, you could say it's 37 degrees south of east if you wanted to use directions, but this is obviously not south and east, this is just like flat tree stuff. So this is my velocity vector. And since it's a velocity vector, I'll just call it v. Vectors have two parts, magnitude and direction. Vectors can also be broken into two other parts. I'm not going to use the word parts, I'll use the word components. A 5 meter per second velocity, diagonally like this, is the same as a 4 meter per second velocity like this, and a 3 meter per second velocity like this. This is horizontal. In the x direction, so I'll call it Vx. And this is vertical in the y direction, so I'll call it Vy. And we're on V is 5 meters per second. In this direction, Vx was 4 meters per second. Vy, I'm going to call it -3 because it's downward. It makes your sensitivity to call it downward negative. And for x, so for the y, sorry, hang on. So now we're talking about two-dimensional vectors, x and y. The positive x direction is to the right, the negative x direction is to the left. The positive y direction is up, the negative y direction is down. Just like math class, vectors are broken into two components, an x component and a y component. And if you want to get technical, you would say vector v is vx plus vy. This doesn't make sense if you do the math. If you do the math, you say, oh, 4 plus 3 is not 5, it's 7. 4 plus 3 is not 5, it's 7. But we're not doing math with scalars. We're doing math with vectors. A 4 meter per second to the right velocity and a 3 meter per second downward velocity at the same time, they are equal to a 5 meter per second velocity at some angle about 37 degrees below horizontal. That does work out. So this vector v is a combination of vx plus vy. Vectors are normally broken into two components, an x and a y component. So v can be vx, vy. If I have some displacement vector d, it looks like this, it could be broken up into dx and dy. If this is my acceleration vector, there's ay, there's ax. For reasons we usually don't break up acceleration, which you'll see later, but very, very common, displacement has two parts, x and y. That's pretty much all we need to learn today. The rest of the stuff you should know. How do we know v is 5 meters per second if we know vx and vy? I'm not even going to ask my babies because it's just so obvious for everyone. V in magnitude, you can't find direction this way, but if you want the magnitude of v, a nice way to write it is the same as absolute value. The absolute value or magnitude of v is the square root of vx squared plus vy squared. Technically, these are also magnitudes, but it's a Pythagorean theorem. Vx squared plus vy squared square root is the magnitude of v. 3 squared plus 4 squared is 19 plus 16, 9 plus 16, so it's 25. Square root of 25 is 5, works out. If you want to find the direction of v, there isn't really a nice nomenclature. Some people write theta for angle, so theta v, the direction of v. If you want to get fancy, can you guys see that? It says direction. is the inverse tangent of Vy over Vx. Since tangent is opposite over adjacent, inverse tangent of opposite over adjacent would be the angle. So that's just trig. We'll do some practice with that. I don't think I really need to go over it, but you're going to see the same thing in trig that you do in physics. What you will see much more in physics, which you also probably know from trig, is this right here. This is how to find v from vx and vy, but hopefully you guys already know how to find vy and vx from v and theta, the angle that it makes with horizontal. So here's my v, here's my theta. How can you find vx and vy if you know v and theta? I erased all my marks, but I don't need them anyway. I'm a strong, independent physics teacher that doesn't need those marks. You guys already know how to find vx and vy. So let's say it's not a nice 3, 4, 5 triangle, it's not a nice number like this hawk. Let's just say I throw my marker at some weird angle. Let's say I throw it at like 17 meters per second at an angle of 57 degrees above horizontal. You can figure out how fast it's moving vertically and how fast it's moving horizontally with some simple trig. And for this whole unit, we're using degrees the whole time. So if you guys are doing radians and pre-calc, yeah, switch your calculator over. We're doing degrees now in physics. But we will switch later for confusing reasons. That's the idea. And this actually confirms what we went over last 2 minutes ago. Is it true that vx squared equals plus vy squared equals v? Yeah, it is, because if you plug in, you get v squared cosine squared theta plus v squared sine squared theta. Well, this is just square root v squared times the square root cosine squared theta plus sine squared theta. And cosine squared plus sine squared, that's just 1. Oh my gosh. Yes, it is equal to v. And what about the tangent thing? Let's try it. What's vy or vx? Vy over vx is v sine theta over v cosine theta. Well, the v's cancel. Sine is opposite over adjacent. Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, so this is opposite over adjacent. Well, that's just tan theta. So if you inverse tan both sides, vy over vx, amazing. That's theta. So this whole lesson was mostly math review, but all the quantities we learned that are vectors, velocity, acceleration, displacement, if we know their magnitude and direction, we can find these two things. They're called components. The horizontal component is usually x. The vertical component is just a little y on the side, and practice those ideas right